Is this thing on? Oh, hi. So, today I'd like to talk about something that I've thought of for quite a while, and that is, what is the antiderivative of round of x? This word function right here. Well, one thing to have in mind is, what does taking an antiderivative of something do? And if you know the absolute value of x, you'll probably know that the antiderivative is like some weird, like x to the power of 2 times the absolute value of... Give me a second, I'm trying to figure out how this thing works again. Divided by x. Which that would be the antiderivative of the absolute value of x, because it takes the sharp edge and it kind of smooths it out, basically it gets closer together to being like the same slope. And if you ever took the antiderivative of the absolute value of x, give me a second, I haven't done this in a while. Come on. Give me a second. Okay, we'll just do this one. This would be the absolute value of x. I can't seem to remember how to do the derivative yet. I know how to do antiderivative. So if we have a function of this, f of x equals that. Oh wait, that's the negative version of that. Okay, so we're gonna do, there we go. So that would be the antiderivative of, did I have this actually just incorrectly oriented? Yeah, I did, never mind. Sorry about that. So this would be the antiderivative of the absolute value of x. So it would take jumps like these, and in a function, it would just cut it and turn it into this little point from it. So whatever the absolute value of, derivative of round of x would be, it would have like all these sort of jumps to it. In fact, I don't even need to figure out what the derivative is, because I can just plug this in to being the function of x, and then that would give you somewhat of a rough estimate. I don't see why it's doing this, because this doesn't seem right. But it'd be kind of close to this with all these choppiness of a corners, like a parabola, except it started 0 here. Now the question is, what do you take a derivative of? The first place, this is just a constant number right here. If you have just x, the antiderivative of that's like x squared divided by 2. But if you have like 2, the antiderivative is just 2x. So we can just probably call it a day and say the round of x, since it's already constant, just times it by x. Okay, I don't know why it didn't show up for the first millisecond. Except this isn't the antiderivative. In fact, it has a ton of gaps. A ton of very nasty gaps. Like by the looks of it, it's got little jumps to it. So this is where I have a different idea on solving for an antiderivative of a weird function that they don't really have an answer for. You take the guess that it has, your guess minus Desmos, how it can like calculate the sum of it, and you simply take that antiderivative and you plug it in to the function. Desmos really doesn't. I don't have the best computer to be running these functions. And by the looks of it, it has created this little tiny parabola of rounds. So by the looks of it, it's probably like a round of x squared, we'll say. I forgot how much this lagged. It's been like 2 years. So anyway, that would be right because it'd be divided by 2. Be right. Well, that would be right. I'm trying to think of how I solved this on the first place. So that would be the correct answer. And if you were to pull up like AI and type it online, it would give you a funny answer like this. Not that, not at all. That would be the answer it gave you. Did I put 0.2? Except, as much as it's like a really close enough answer, this isn't the answer at all. That is the answer. And that right there is a function for round of x. That's the antiderivative of the function round of x. And the reason why I upload this video is because AI got pretty close to solving it, and I was like, you know what, I don't want AI to take credit for this. And you're like, oh, I just stole off AI and did like an easy thing for it. Well, here is a really funny function that I did once. X minus the round of x. Fine. Was it this one? Was it this? Give me a second. Yeah. This right here is a really crazy piecewise function that I did quite a very long time ago. I have probably no idea how I did this to begin with. And I'm going to attempt to remember how I solved this function. I'm going to start by initializing it as that. And this is going to be the answer right here. Hopefully I did this right. 0 x f of a dA. And that should be hidden. Give me a second. Is that going to? Okay, it's not going to lag. So this is going to be the answer right here. So first things first, this is just going to be like a regular a. So we're going to just multiply that by x, divide it by 2. Now what we have is this piecewise thing. Now when you're starting off with a derivative, usually it always starts at 0. So this part right here is correct. In fact, this part probably going to here is correct as well. Except this isn't correct where it has these jumps. I don't know if you can actually see my mouse. Kind of like rushing this video. So what we're going to do is guess how much of a change this has. This is probably like around a 0.5 change. So what we want to do is find a round function where this right here is probably just going to be 0 on both ends. So if we just did round squared, x squared, that wouldn't give us a 0. That would, except it jumps by 1. I'm so not up for this right now. Why am I trying this? I'll use an absolute value function just so we have it. We'll have x move forward by 5. Here we go. This will be my other function. There. Now, this one needs to add by this much. So that's like add up to there, add up to there. And this one has to minus. So this already isn't the right function because there should be an easier way to actually figure out this piecewise function. You know what? Scrap that idea. I'm not going to figure this out like that last one because I kind of want to figure this out way better. I want to try. We're going to ignore this side for right now. We're going to focus just on this. So what we need to do is find the maximum number of this to the change of this. Maybe. So here is that's going to be a new test function. X. The value at this one minus the value right at this one. So that's a change. Negative. It's 5. What I need to do is this. Points. Second, how do I? Give me a second, I'm not sure how to do this. Now, okay, we're gonna have to just do it this way, where we don't really see how everything is. You know what? I'm not really sure how to do that actually. I'm trying to think. It's not coming up to me yet. Yeah, we're gonna cheese it. So here's the answer. Wait until it loads. I don't know why it's only showing that portion. And then we're going to just minus it by dx so that we can get the missing function. That is neat. Is that really it? Man, what was I taking when I did this? Okay, looks like kind of like the starting function. Give me a second, was this even right? No, that wasn't right at all. I'm a nut job for trying this. I like this because it's not these like warped things, so it should be easier to work with. What if I do that? Just see how it looks. Yeah, that's warping. So this is part of it. That is part of the equation. Oh wait, give me a second. I wasn't paying attention to which line it was. I have the purple one, not orange. Yeah, the purple one. I want straight lines. These are bending. So yeah, that. That is right. So what we need to do is find this purple function. So it looks a lot like f of x so it slopes downwards here, but it goes up. So the slope of this. I usually would just say it right there. 0.25. Oh, this thing's got half the slope of it. This is one. This is the top at. So this is half. This is at around just half slope, and then this is some other slope. Give me a split second as I just cheat and pull up what I did in the past. this one. There we go. I'm pulling up the old function just to make sure that this is actually the right one. I did. Yep, starts at 0, goes up by some degree. Oh, I gotta not look at it, I'm just trying to look at the original function. Okay, so this, yeah, this is the right starting function I did right here. How did I figure this out? Is a different question. So this is clearly some round of x. Or it looks a bit like negative round of xx. Because this is, it's piecewise, but it's also not going on a slope. Is it x squared? No. Because this has to be at 0.5. Slope of this has to be an active number, meaning not 0. That one looks pretty close. It did that one. Actually, that one's really close. Isn't that? Yeah, it's got one side of it. Right? No, well, almost. You know what, we'll do this as the next function. Although, this is going in the wrong direction. Okay, we'll have this as a different function to it. X. We're simply just breaking it apart, one by one, seeing what we get. Yay! We went in the wrong direction. Plus side would be if it smoothed it out, or it'd be like all flat. What am I forgetting here? Actually, let me scrap that part. Here's a function right there. what do we have to work with? We have round of x minus round of x squared plus round x times 0.5 minus 1. That's what we have to work with. What am I missing here? I feel like this could be simplified, and I'm just not seeing it. Okay. First guess is this would be divided by 2. I haven't done. Get 0.5 of x. I haven't done calculus in so long. Is that it? I think that was the actual function right here. Oh my god, I think I actually got it first try, somewhat. Taking a while to load because it's just a ton of derivatives. Well, now it at least shows that it's not trying to say add the slider for value d, but it's not showing up on here. Let's hide, reshow, and usually it'll pop up with the current thing. I meant to do this one. My fault. Yes. That's good. That's really good. Not gonna zoom out that much, but right now it looks like it is a round of x to the power of 3, which is what we have left. You didn't see me type 2. That didn't happen. Question is divide by 3 because it looks like it's past halfway point. Now this again could be the wrong answer. Yeah, not quite, but it looked really close. Go like this. Now wait for it to load. Closer we get, the better. I feel like this just didn't load right there. We're going to hide that. And there's our current function for how close we are. Which this is really close. This is really close. Except it is not the function because it's got these tiny little gaps right there. And it looks really close that it shouldn't be that far of a change. Are we using this function? No, this is the original one. This is, well, that's just the copy of the original. I don't need that. Heck, in fact, that probably threw me off. Come on. Pretty sure it's not that far off. So one good way of telling if you're on the right path would be to take the derivative, if I could do it. Does it have to be like this? Same thing as the other one. Oh, that's how you do it. And it's still the same slope and everything. I forgot it's on that side. Whoops. I forget. Now. I swear it wasn't this much of a change, really? Okay, let me see. Show me the answer. So that's the case, it's still like a power of 3 function. It's like going down, slowing, 0, then back up. Well, it's this deaccelerating, I should say. There we go. So that's the answer. We'll do it this way. Dx minus the main answer. Because these two are like really close. Like it shouldn't have like one here and then one way up there probably. And we wait for Desmos to load. Oh, that looks really close. That looks like super close. That looks just like a step of round of x. Divided by, is that 4 or 8? I think that's 8. Let's say 4. Yeah, that should be 8. You know what, I'm really positive that that's just 8. I'm just going to plug that in right now. There we go. We did it. We did it. We got it. Solving the derivative of round functions using Desmos's sum calculator. Antiderivative of some functions. It's like the derivative of, you want to, not some functions, round functions. Because the antiderivative, well, the derivative of the round of x would be a flat 0 on all values, except it would be like some random number of infinity when it hits right here. Oh, this long piece of shit is the... I can't say that on YouTube. Oh, okay. I'm just gonna not put this as for kids. Well, I'm not going to leave it like this though. I'm going to simplify this function before we go, because that is disgusting to look at. So we got round times 0.5, 0.5, okay, minus 6. There's 1 round, there's 2 round, there's 3 round, there's 4 round, there's 5. So these are all rounded. So we can just take out the round of each of these and just take the round of x times all of this. Why is it doing that? Oh yeah, right. Making sure it's still the same function. It's still showing the ghost of that function, so I'm just going to delete it since we don't really need it. Now this entire thing, oh, almost forgot. The x derivative must still be the same. Yep, there we go. Antiderivative of that is still this. And there's no gaps in this, so that is the correct function, and you can graph it on forever. Well, if you do like that sum formula in Desmos, it like lags like crazy. Let's see, x, 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 that's still around, that's still around, and that's just a plain x. X, we'll go with this to this one. And since that's going to be rounded, and oh, I messed up. I messed up simplifying the function. At times I do that. Plus minus that plus 1/2. Where did I get the 1? Oh yeah, from that. 0.5. This can just be 1/4, can it? There we go. I don't know why I had it on that crazy number. That can just be x divided by 2. What did I mess up here? Took this function right here and I moved it right there. I have x minus right around in there, so that just becomes 1/4 plus that. Oh, there's my answer. And right here we can simplify it too, because these are both x over 2 of x plus 1. And I'd say that's a simplified answer. So right here, direction head, and I don't think I simplified it this far before. But right here is the antiderivative of parentheses x minus round of x plus 0.5 times and parentheses times round of x minus 1. And there you have it. Good luck trying that, AI. In fact, I'll in fact plug it in to see what AI thinks it is. Oh, and I'm using Google AI in case anyone notices. I don't like AI personally. But yeah. Oh wow, even the image it pulled up for the antiderivative of round of x is like all choppy. Okay. Gotta make sure I'm doing this right, otherwise it's just going to be the wrong function to begin with. Alright, let's see what AI thinks it is. Is a piecewise function consisting of parallel something. Give me a somewhat okay answer. Oh yeah, it's popping up the image of what it had. Oh, it gave me the result. Okay. So, here's what the AI thinks it is. I'm literally just doing this for random things. It's having two parentheses. Oh yeah. That is that the original? No, it's not the original function. I think that's it. Let me double check real quick. Gotta make sure I type this in right. I think that was it. Yep. That's what AI thinks the answer is versus the actual answer. And AI couldn't have simplified it. Didn't simplify it though. Probably could have. Could I have simplified this more? I don't know. Probably. But yeah, that is, I guess it. How off was it anyways? Let me see. Original function minus. Oh, there's already a function of that. Haven't used this in a while. Oh yeah. It's missing. Square root of 3 is. Square root of the round is not correct. Which is why this is off-centered. Somewhere. Yeah. There you go. A rounded function and its antiderivative. I hope you enjoyed this video. I'm sorry it took this long, but I can just say AI sucks. It can't even give me the right function for it. Thank you for watching this video. Goodbye.